Hi, Mr. Wendell here. Today we're going to take a look at our density lab. We have a number of supplies. We'll take a look at our instructions first. So the purpose of this lab activity is to measure the volume and mass of different solids. We're also going to take a look at two different liquids. There are slightly different procedures for each. So prior to doing the lab, please take a look at the backgrounds. It goes over information including how to calculate volume of regularly shaped solids. It includes a cylinder calculation, so please take a look at those. Density is a characteristic physical property, and each object that we have will have a different density. You will also have an unknown. This unknown will be a smaller cube in the blue box with all of the other items. The small cube is made out of the same material as one of the larger cubes, and you're going to use density to try to figure out which one it matches up with. All right, for the first procedure, we're going to be taking a look at the density of two different liquids. You will have two graduated cylinders, each 10 milliliters. First thing you will do is you're going to take one of the graduated cylinders, you're going to place that on the balance, and you're going to hit the re-zero button. The balance should say 0. Now any little bit of air moving over the balance, again, you'll see it will move up and down. They're very sensitive. As you take that off, you'll notice that the balance goes to a negative number. That's actually the mass of your graduated cylinder. The first liquid that we're going to use is going to be alcohol. You will pour yourself between 5 and 10 milliliters of the liquid. The volume in our graduated cylinder with alcohol is 5.9 milliliters. Once you've gotten your sample, you'll put the graduated cylinder back on your balance, and the mass that is showing on the balance should be the mass of your liquid inside the graduated cylinder. In this case, it's 4.64 grams. Place that data on your data table. The mass was 4.64 grams we got from our balance, and the volume of 5.9 milliliters we read directly from our graduated cylinder. In order to measure the density of the second fluid, which is going to be water, you're going to again have to re-zero your balance. The second graduated cylinder on the balance, hit re-zero. You will also get between 5 and 10 milliliters of the water. In this case, we've gotten 6.6 milliliters of water. Place the graduated cylinder back on the balance. For the 6.6 milliliters of water, we've got a mass of 6.43 grams. With this information, you're going to calculate the density of both liquids. So you'll take the mass divided by the volume. The second set of procedures deals with a number of solids in our blue sample box. Each one of the samples underneath has a symbol. This one is aluminum. Our second sample is steel. You want to take only one sample out at a time so you know where it goes. A number of the wood pieces are marked with the type of wood they are. The small cube is going to be your unknown, and the cylinder will either be a small cylinder that's in your box or a polypropylene cylinder, which is red in color. It's a type of plastic that your teacher will give you. We're going to do the first sample, which is copper. Copper is a reddish metal. We're going to take it, place it on our balance, and we get a mass of 146.56 grams. You're then going to take the copper cube and you're going to measure the length. And the length of this copper cube is 2.45 centimeters. You're also going to measure the width of the cube. This one is 2.50 centimeters. And you'll measure the height. And the height is also 2.50 centimeters. So with our length, width, and height, you're going to multiply those three together to get our volume. Once you've calculated the volume, you're going to find your density by taking the mass divided by volume. Once you're done with the copper, you're going to run down through the other samples. You will not use all the samples in the box. We're going to use copper, steel, aluminum, nylon, which is opaque, the acrylic, which is a clear cube, and we're only going to use one of the wood blocks. We'll use the oak wood block. After you've gathered the data, you can go ahead and calculate all the densities. Once you're finished doing that, your teacher will supply you with a list of the known densities for these items. And you're going to do a percent error calculation. Once you've finished with the percent error calculations, there are a number of conclusion questions that you can do. Please make sure that you answer all of the conclusion questions in full sentences. In addition, there's also a thinking ahead item. Make sure that you also answer that.